One of the major questions we'd really like to understand is what is dark matter, this mass that is the dominant form of matter in the universe but is very hard to detect on Earth. So one way that we can actually study that is to use computer simulations through XSEDE to look at how dark matter should clump around galaxies like the Milky Way and how it should form around smaller galaxies as well. So that's one of the main goals of our research. It's possible to do very approximate work with pencil and paper, but when you really want to get the details right and understand what predictions of the theory are and how structure should form in the universe, it's a very multi-scale process with a lot of different processes going on. So we need to be able to simulate these processes together, because otherwise, if you don't get one, you don't get the entire thing right at the end. Well, most of my collaborators use XSEDE resources. They can all access the same data in the same central repository with the same tools, so everybody knows exactly what they're getting and can get it whenever is necessary. When we try to simulate the universe or understand the evolution of structure in the universe, we need to do a lot of repeated calculations, and so the supercomputing aspect of that, highly parallel supercomputing, is our bread and butter, really. We produce extremely large data sets, terabytes upon terabytes. We often can look at, say, the dark matter by itself and then separate out gas and stars and try to see whether they behave the same way or whether they show different features. We can even split things up based on properties of the gas. So maybe the hot gas behaves very differently from cold gas where stars form. And that visual impression really gives us something important and feeds back into our research in an important way. Since we don't actually detect dark matter directly on Earth yet, but only see it through its gravitational influences, we have to rely on astrophysical observations, and the theory is done through computer simulations, which wouldn't be possible without resources like XSEDE provides.